I'll be quietly listening. We are on lesson 4-1 today, Intro to Similarity. Our unit guide is up online. Let's go take a quick peek at our unit guide. For our geometry unit guide, it's nice and short. We have a lesson, and then tomorrow is a quiz. And then we have a lesson, a quiz, and then a test. We have a total of 5 lessons, 2 quizzes, 1 test. And I can zoom in here a little bit more so that people can see in the back. If my computer would behave. There it goes, dismiss. All right. So let's go ahead and start on the notes. Who would like to read the objective with a quiet raised hand? Gunnar, thank you.
Determine if two triangles are similar using transformations, the AA theorem and the SSS theorem.
There it is. And you don't know what those are yet, but you will by the end of today. Can you please turn in your card, Gunnar? Thank you. All right, so let's start off with some vocab. What is the word similar even asking? So we know that the word congruent from our last unit, unit 3, meant everything is the same. Angles are the same, angles are congruent, and that the side lengths are the same, the side lengths are congruent. Similar is similar to the word congruent. So similar means that the corresponding angles, like you can think of angle C right here and angle F right here, those angles should still be congruent. So write down the word congruent. Angles are still congruent, but the sides are not congruent anymore. I'm not going to write the word not congruent because there's still something special about the angles, or special about the sides. Check out these sides. This side CA and this side DF, that has the same ratio as the side AB and DE. So we want to use the word proportional. So this is where I get to speak, and you can either take notes on this or not. It's totally optional. In our last unit, unit 3, we talked about congruence transformations. We had 3 different transformations. If you could use those 3 transformations to map one object onto another, then we could say we have now proven that these 2 objects are congruent. Those transformations were a translation, moving, a rotation, and a reflection. Today we're adding one more transformation in the mix. It's the only other one that we've learned about. Does anyone remember with a quiet raised hand what that last transformation is, Jose? Dilation. Dilation will grow or shrink the shape, but that now means that it's no longer congruent sides, it's proportional sides. Perfect, you can turn in your card, Jose, thank you. So, that's kind of one of the homework assignments I just kind of gave you in words. Let's go ahead and talk about the equations, the math that comes from this one rule, what it means to be similar. So it means that the measure of angle A is equal to the measure of angle D. A and D, hey, they're both right angles. Can someone else give me a quiet raised hand to give me another pair of angles that are congruent? Yes, Andres.
Angle C and angle F.
Yeah, how do you say that formally? The measure of...
The measure of angle C and F.
The measure of angle C is
equal to the measure of angle F.
There it is. Thank you. Can you please turn in your card? Is there another person with their participation card that can do the final formula? Gunner's a good backup. He's had his card in though. What's the other one? There's one more angle pair. Yeah, Fernando?
The measure of angle B is equal to the measure of angle E.
There it is. And again, I'm just really making sure because I'm not getting too much feedback from you guys yet. A and D, they're the same angles. C and F, these 2 are the same angles, and B and E, these 2 are the same angles. All right. That's kind of the easier part. Here's the harder part. We got the congruent statement down. Now we have to get the proportional statement down. Thank you. Proportional just means if I have a fraction, if I divide this length DE, this length right here, maybe it was 10, I don't know, and I divide this length by this length, I will get some number. I'll get this ratio, and I'll eventually tell you what that's known as. But that ratio is the same ratio if I divided this length by this length. So how do I write that down? I say, well, if I divided line segment DE by line segment AB, that would be equal to line segment, I guess we can say EF, just going around the triangle, EF So this line segment EF is that hypotenuse of that red triangle. If I divide line segment EF by line segment BC. And I need a quiet raised hand for the final proportion, the final fraction. Divide what by what, and it should still be the same number. It should be the same proportion. We've got the bottom legs. We've got the hypotenuse. We're missing 2 more sides. Who can say them and in the right order? Are we doing big divided by small or small divided by big? The order does matter. Hopefully someone with their card. Gunnar is our backup though. Thank you, Gunnar, for having a quiet raised hand. Andres is another backup. We have 3 possible backups now. I would prefer someone new to try this one out. There's no harm in trying. Nothing bad happens. All right, Gunnar's been waiting patiently. Thank you, Gunnar.
DF
Line segment DF.
divided by a line segment AC.
There it is. Line segment RAC.
What?
Yeah, you have it right. Gunner's just saying, hey, if I divide this length by this length, I will still get the same number. Each of these is proportional to one another. This word proportional just means if I divide them, I get the same number here, I get the same number here, I get the same number here. So we're taking it a step further. We can't just say it's equal to, we have to say it's proportional to. All right. And this ratio, this number here, maybe this number was 2, 2, and 2. That number is known as the scale factor. And I'm going to be using that word a lot. And you've already heard this word before. Whenever we, well, I guess I didn't technically use scale factor. I said factor, though. Whenever we were dealing with dilations in the last semester, we were always saying, by what factor is your dilation? Oh, you're dilating this triangle by a factor of 3? Well, now it's 3 times as big. You're dilating this triangle by a factor of a half? Well, it's a half as big. It's smaller now. All right, so this symbol right here means similar. Question, Andres.
Can you define scale factor?
Scale factor is what happens when you divide one length by another. And it can be either way. It can be the small divided by the big or the big divided by small. It doesn't matter. As long as you're going the same direction over and over, always small to big, always small to big.
Any length? Or
Any length, yeah. All right, so question, Gunnar.
Is there any other words for scale factor?
Synonyms for scale factor. I guess you can kind of replace the word scale with dilation factor, but I don't use that one very often.
How does that sound like?
Yeah, it doesn't roll off the tongue. All right, good questions. Again, so this symbol means similar. So this is asking, is triangle ABC similar to triangle DEF? We have to check all of these 4 things. I need to check, well, technically 2 things. Are all the angles congruent? Are all the side lengths proportional? If those 2 things are true, I have met the definition of similar, and I can now conclude, yes, those 2 triangles are similar. So again, I'm going to check the angles first. Those are the easiest thing. If one of the angles is off, then they're obviously not similar. In fact, I don't even have the length of the sides. I can only check the angles. So let's check here. Is 43 equal to 43? We can all nod our heads, yes. Make sure that we have a quiet raised hand. I don't know who it was. Is 84 equal to 84? You'll nod your heads or shake your heads. No. Okay, well, that's the answer. No. It's that easy.
No, sir.
No, and you can, if you want to be more specific, you can say because the angles are not congruent. The angles all had to be the same in that case, and they weren't.
Sir.
There should be no talking unless you guys are answering questions, Julian and Fernando.
Is it to say? Can you go, please?
Yes.
Thank you.
again, if you have a question, I would prefer a quiet raised hand. So, are those two triangles similar? And you'll say no, because the angles are not congruent. All right, so let's practice writing correct similarity statements, and I'll show you what some incorrect similarity statements would be. So it's kind of hard to see in these triangles over here, but let's just randomly decide. I'm going to go, I don't know, clockwise from A to B to C. So I'm going to write over here, triangle ABC. Triangle ABC. And I want to say is similar to triangle. Okay. The first letter that I should write should have the same angle, or an angle that is congruent to angle A. So over here on this, I think it's red, it might be green, but this red triangle, the angle 40, okay, that's this angle D. So the first letter that I have to write to be correct is angle D. I will repeat that one more time. If I wrote A, and A had 40 degrees, the other angle that had 40 degrees was D, and that's why I have to write D here. The next letter that I wrote was B, and angle B had 106 degrees. Well, 106 degrees is E, so I have to write E and then F. You have to write them in the correct order. Here's an incorrect order. If I did triangle ABC is similar to triangle, I could do DFE. I could switch this order. Well, you're still talking about the right triangle. You're not saying the similarity statement correct. So what I want you to do as I stop the recording is I want you to write one more correct statement and one more incorrect statement at least. And if you're still waiting, write a bunch more. There's quite a few correct and a ton of incorrect statements that you can write. All right, so quiet raised hands. Who wants to give me an example? Yes, Sergio.
The triangle BCA similar to
EFD. I want everyone to try to determine if Sergio is correct or incorrect. Maybe you already wrote one of those statements. BCA. BCA and EFD. EFD. Give me a thumbs up or thumbs down. All right, thank you. All right, can someone give me an incorrect statement? Julian?
Triangle CBA is similar to triangle
DEF. So CBA, DEF. All right. So hopefully people will be doing thumbs down if that is indeed incorrect. Is it correct or incorrect? Thumbs down for incorrect, thumbs up for correct. I know, it'll become a double negative at that point. I'm going to keep the same system. All right. Good job, Julian. You have it. Did anyone else want to give a similar statement before we move on? Andres? Is it going to be a correct or an incorrect one?
Correct. Triangle CBA is similar to triangle FED.
CBA is similar to triangle, say again?
FED.
FED?
Yeah.
So CBA, FED. Yeah, that one is correct. Thank you. Anyone else want to give it a shot as well? Otherwise, we're moving on. All right, so now we're going to talk about two theorems. First is the angle-angle theorem. Whenever you have an A, assume it means angle. Whenever it's an S, assume it's side. So I pronounce this as angle-angle theorem. And when I come down here to SSS, I don't say SSS theorem, I say side-side-side theorem. These are theorems, I mean, the side-side-side theorem, you've seen this before. If it looks familiar, this was a congruent statement. But when I'm talking about are triangles similar, it switches slightly. All right, let's talk about the angle-angle theorem. We haven't seen him before. For a triangle, if two angles of a triangle are congruent to, am I reading this right? For a triangle, if two angles of a triangle are congruent to the other, then the triangles are, what's the word that I'm going to be filling in here? The thing that we're talking about today. Quiet raised hand. Jose?
Similar.
Similar, there it is. Thank you. That's an interesting statement. How did you get that, Mr. Sindel? So, everything that I'm doing today comes from this definition. I'm using this definition over and over and over again to generate equations, to generate these theorems. All it means, in order to be similar, the corresponding angles are congruent. Angles are equal to each other. The sides are proportional to each other. Ignore this piece. If the angles are similar to each other, or if the angles are congruent to each other, well, we have to choose all three angles, right? This angle has to be the same, this angle has to be the same, and this angle has to be the same. I just told you right now, hey, that third guy, don't worry about him. Why am I allowed to do that? Quiet raised hands, anyone? Not enough quiet raised hands. I want you to try to talk in groups of 3 to 4, big groups. I'm expecting people to stand up for this. Talk in groups of 3 to 4. Why am I allowed to do this? So please, I need 100% of you to stand up, get in groups of 3 to 4. Why am I allowed to ignore that third angle? I'm saying, hey, 2 angles is fine. And I'll give you guys a hint as you talk about this problem. There are 180 degrees in any triangle. All right, I need someone aside from Gunnar and aside from Sergio who has spoken already. Someone repeat what they have said. Why can we ignore that third angle? Fernando.
So if you have 2 angles, you could find the third angle.
Okay, how can I find the third angles if I have those 2 angles?
Do like 180 minus. Oh, you could add those 2 angles and then subtract it from 180, and then you could.
Okay, and that's the key point. So if you want to make a note, you can. I'm going to make it in yellow down here. We can always find the third angle.
That's the second version.
Because, am I making a mistake somewhere? What is the mistake?
You said can twice.
All right, thank you. Anyone that saw it, you can log it. You can always find the third angle because a triangle, I'm being very informal here. I should technically be saying the interior angles of a triangle sums to 180. I'm just going to say a triangle has 180 degrees. Question, Sergio.
Can you cross out any angle? Not just instead of always that third one, can you cross the first one, second?
I think the key issue is just make sure you've got 2 of the same, and then you're good. So just look for 2 of the same, and then ignore whatever else happens, as long as you have 2 that are the same. Gunnar?
No, you could fix that 2 or 3. It looks like a 2.
This 3 right here looks like a 2? Okay, I can fix that.
Does it not look like a 2?
All right, let's go on to example number 2. Everyone is on the backside with me. Which of the triangles are similar to triangle A? So we start with this black triangle, and I'm given a blue and a red triangle. Okay, it helps. I'm going to give you this hint. It helps to find all 3 of these angles. So I can always find this third angle. Let's go ahead and do that right now. So if this is 87 and 53, I can add those together. 87 plus 53. That sums 7 and 3 is 10. Carry the 1. 1 plus 8 is 9. 9 plus 5 is 14. It adds up to 140. With a quiet raised hand, therefore, this remaining angle is... Only 3 people can do that in their heads. Andres?
140 degrees.
This angle right here is 140 degrees.
It's 140.
No.
These 2 angles add up to 140.
It's 40.
There it is. Thank you. Everyone write it down. It's 40 degrees. That looks like a 400. There it is. It's 40 degrees. All right, so I'm going to come down to triangle B and C. Is it a question or an answer?
Kind of starting us off.
Oh, what did you see?
So can you do instead of doing this math, can you just
No.
assume it?
You cannot assume, unfortunately. You do have to calculate it.
No. Did you not tell us?
Thank you. Yes.
Did you not tell us that all triangles add up to 180?
All the interior angles of a triangle add up to 180.
Yes.
So we can assume
We can assume those are going to be 180 and they'll be exactly the same.
Okay, let me talk about it a little bit more, and hopefully I will explain it in this explanation. So if I checked triangle C, 87 and 53, even with the information that was given, it's clear that I matched up two angles. By the angle-angle theorem, I can say yes. I can circle C. I can say yes. C is definitely similar. It might not be congruent, but it's definitely similar. If I didn't have the information that this was 40 and I only saw 87 and no other angle, I can't assume this is the angle theorem. No, it's angle-angle theorem. I have to have at least two angles to match. So I would either have to calculate this angle, which would end up being 53, or I would have to calculate this angle, which we just did, and we found that it was 40 degrees. Now I can match up two angles, 40, 87, 40, 87. I can now use the angle-angle theorem to say, yes, all of the angles must be congruent by the angle-angle theorem. Therefore, both B and C, correct answer is C here, are similar to triangle A.
I have that. Well, I raised it because I thought he was going to say it was wrong.
Are there any lingering questions from the angle-angle theorem? Otherwise, I'm moving on to the side-side-side theorem.
You just said we couldn't assume.
So I think it might be a distinction between what assume means. If you're actually kind of doing the math in your head, you're not assuming, you're doing the proof. But you do have to somehow calculate one of those angles. You either have to calculate this angle or this angle to match two angles. All right, so side-side-side theorem. In a triangle, if all three corresponding side lengths have the same scale factor, they are all proportional, then the triangles are what? Quiet raised hand, nice and easy here. I need to get, come on, there's so many people that have cards out. I'm strictly making this one for only people that do not have cards. The triangles must be what if all three corresponding side lengths have the same scale factor? Jenny. Ooh, careful, congruent was last unit. Similar, thank you. Thank you, Andres, for helping. All right, so now instead of checking all, there should be no more talking, guys. So now that we are on to side-side theorem, we're really checking the proportion, and I need to make sure that they all match up. So I'm going to do triangle DEF with you guys, and then you guys have the harder one, GHI. So it's very clear that the long side and the long side should match up. So I'm just going to randomly say I'm going to do the black triangle divided by the blue triangle. The big divided by small here. So everyone write this down. I'm going to do big over small. So when we do this other triangle, I should also be doing big divided by small to get the same scale factor, right? Actually, it doesn't matter. You could switch it and do small divided by big for a different triangle. As long as I'm doing a consistent triangle, that's all that matters. So the big side, the black's 15. I'm just color coding my triangles. The black triangle had 15, and then the long side for the blue triangle was 10. I have to write all three of these. This theorem up here says all three of these need to be written down. Okay, the next one. The medium size length was 9. The medium size length, is it 6 or 4? It's 6. That should be equal to, okay, I should do the small. The small side of the big triangle is 6. The small side for the small triangle is 4. So 6 divided by 4. All of these numbers need to be the same, which means I need to reduce. Here we go. I'm going to reduce. 15 and 10, I can divide the top and bottom by 5. So if I divide by 5, I get 3 over 2. All right, that doesn't mean anything on its own. Ooh, 9 over 6, I can divide the top and bottom by what? Gunner.
Oh, can I look at the card? Can I tell someone the card? Or like give
You can
them
just
an idea?
go for it.
I want someone to have put their card in.
I really appreciate you doing that.
3.
Divide the top and bottom by 3, and I get 3 over 6 divided by 3?
Yeah,
2. Hey, check this out. We're getting the same fraction, This other fraction has to be the same, otherwise it breaks it. How do I reduce 6 over 4, Sergio?
2,
Divided by 2, and I get
3, and 2.
3 over 2. Hey, all of these fractions were the same. All of these scale factors were the same. Therefore, we can conclude that the black triangle and the blue triangle are similar. So I'm going to go ahead and leave the blue triangle circled. That is an answer. But now we need to do the same thing, and this is what you guys are going to do on your own now. I'm going to match up and make sure you're always doing black triangle over red triangle or always doing red triangle over black triangle consistently. It doesn't matter which one over which one. Write these all as a fraction now. Give me a thumbs up if you guys want to do this as a class. Thumbs down if you want to try to do it individually. Quick poll. It's divided 50-50. More votes, more votes. Okay, we're doing it individually. Go for it. All right, so our final example. Quiet raise hand. Someone walk me through it. Sergio, go.
So I did 16 divided by 15. Similar or equal?
It has to be equal to because these all have to be the same fraction. So keep going. 16 over 15.
9.
7 over 9. Good. Keep going.
Wait, that's the same teacher. I said 10 and 9.
Oh, 10 and 9? Oh. That makes more sense because that's the actual correct one. Okay, and then
Equals to 7 divided by 6.
7 divided by 6. Thank you. And therefore you concluded
That's not the same because it's the only factor is 1.
yeah. No, those are not the same answers. They can't even be divided. It looks close, but it's not. So the final answer, A, B, C, or D? A. There it is. All right, any questions up to this point? Then let's go ahead and do our fist of 5 objective. Can you determine if two triangles are similar using transformations? Angle-angle theorem, side-side-side theorem. Give me a fist of 5. I see a 5, a 4, a 5, a 5, a 4, a 4, a 5, a 4, a 4, a 4, and a 4. All right, thank you guys. You may begin on the homework. Please begin within the next 60 seconds.